Hello everyone, myself Ketan Bausa, Assistant Professor in LJ Engineering College, Ahmedabad. In today's session, we discuss about device driver, interrupt and interrupt service mechanism from chapter number 3. And today's topic we discuss about the interrupt sources. Now, what exactly the interrupt handling mechanism? Let us see that we already discussed in the previous session. So now we go ahead and we discuss about the different types of interrupt. So first of all, we discuss about the different types of interrupt, like we're talking about the hardware interrupt and software interrupt. Hardware source can be internal or external for the interrupt of ongoing routine and thereby division to correspond the ISR, means it will correspond the interrupt service routine mechanism. So the internal source from the devices differ in different processor or microprocessor or devices and their various of families. So in terms of the external source and the port, it's also differ in the different processors and microcontrollers. So basically in terms of the hardware devices, sources of interrupt, we're talking about the hardware interrupt and software interrupt. In terms of the hardware part, we're talking about the two types of interrupt mechanism in terms of the internal and external mechanism. Each of the interrupt source or the group of the interrupt source demand a temporary transfer of control from the presently executed routine routing to the ISR corresponding to the source. So when the source is not masked, means it is not termed or it is not related with the any other masking or resources. Internal hardware devices sources. In terms of the internal hardware devices sources, we are talking about the parallel port, USART in terms of a universal synchronous asynchronous receiver and transmitter, serial receiver port, noise, friend error, ideal, RR, RDRR, and 6, 8, 11. So these are the different types of processors that we discuss about the communication configurable port. Synchronous receiver by computations, UART, serial transmitter port transmission complete, for example TDI means transfer data register MP. Synchronous transmission of the byte complete. ADC start of conversation in terms of the transmitted data from analog to digital conversation in terms of a sensor part. Pulse accumulator overflow, real-time clock time outputs or outs, watchdog timer reset, timer overflow and on-time output, timer computation with the output compare resistors and timer capture on input. So here we discuss about the different types of peripherals, or you can say that the different types of hardware internal device resources. Now software error related resources, or we are talking about resources that related to the software. In terms of the software part, means it is not dealing with the hardware portion. Now how it will discuss. So devices by a zero detection or the TRAP by the hardware, overflow detection by the hardware, underflow detection by the hardware, illegal output detection by the hardware. So these are the different types of resources that we discuss about hardware and software portions. Now we're talking about the example of software error, exceptional or exceptors or TRAP related source related sources. Now the internal or interrupt of an ongoing program consumption in certain processor, division by zero, and also known as generated by a software trap. So IAT is one of the best examples to generate the different types of interrupt in terms of the software portion. Overflow detection is talking about the two interrupts, as it also generates the IAT2. So there are the two types of interrupt mechanism in terms of the software portions. If we are talking about 8085 or 806, we are talking about the two interrupts, type 0 and type 2. By hardware with the ALU port of a processor. So software source for interrupt are related to the software detection, computation error, or expectational condition during the execution, and that on executing a SWI software interrupt instruction, which is the processor interrupt or ongoing routine. Now, software interrupt instructions if you're talking about the software interrupt, then how the instruction it will work. Software instructions are also used for tracking some runtime error conditions called accruing exceptions or exceptions, and executing the exceptional handle on catching the exceptions. Now, if you're talking about the multiple sources or interrupt, means if you have to deal with the multiple data at a time, so you have to deal with the multiple devices, right? So processor hardware assigning the priority PHW to each source, including the trap or exceptions or source group of pre-assumed priorities or the level or a time. So PHWs represent the hardware presumed priority for the source or the group and assume the number from 0, 1, 2, 3 up to k and m minus 1. So let PHW is equal to 0 means the highest priority, PHW1 is equal to next lowest priority, and PHW is equal to m minus 1 is assigning the lowest priority. So means if PHW is equal to 1, we can say that's a lower one. So 0 is a higher one. So we have to set the different types of priority as we have discussed or dealing with the multiple inputs or multiple devices at a time, or we have to discuss about the multiple interrupts. So now when we discuss about multiple inputs, when we discuss about the multiple types of input polarities, then we have to discuss a vectorized priority pooling method. In terms of the vectorized priority pooling method, a processor interrupt mechanism may internally provide for the number of vectors ISR, vector DDRs, assigning the ISR vector address as well as a PHW, means it's assigning the different types of priority. So that is called at the end of each instruction cycle for the highest priority source among those enabled and pending. So vectorized priority in 8086 are as per the n time. So n time is equal to 0, it's the highest priority, and n time is equal to 0 cos f, it's assigning the lowest priority. Basically, when we're talking about the vector, then we have to take the two addresses. So we are taking the 2 bytes of 88 bits, right? So basically, it's assigning a vector. And similarly, for the n time is equal to 0, it's assigning the highest priority, and n time 0 cos f, it's assigning the lowest priority. So here we discuss about different types of priority in terms of the interrelated mechanism. Now we discuss about the context. Now, what exactly the meaning of context? First of all, the things and the question arise in your mind. What is context? Context of a program must include the program counter as well as the program status register, stack pointer, and may include the processor register. So the context may be at a register set or at the separate memory block for the stack. A register set or memory block can hold the context information. So when we're talking about the context, when we're talking about the data, then we have to take care of the different types of register. We have to take care about the counters, status words, status pointer, or different types of processors and registers. So basically, when we're talking about the context, ultimately we have to discuss about the registers. Present CPU state, which means the register, may include the ID of the process interrupted or functions of a number. Now, the current program context, what exactly the context containing? So as I already told you, it contains the program counter, stack pointer, processor state registers, and other CPU registers. Now we discuss about the context switching. What exactly the meaning of context switching? Context switching means saving the context of interrupt routine or functions or tasks and retrieving or loading the new context of a routine or task to execute a next instruction. So basically, in terms of the context switching, we have to discuss or deal with the number of tasks, right? We have to discuss about the number of tasks which is going on in parallel, or you can say that in synchronous manner, means one after another. So we have to take care of each and every task, load the new task, and complete the previous task as per the execution of that. So here we can see that the context switching for the new routine and another switch on return routine. So basically, as you can see, the current routine on switch on the next routine on context switching. So basically, the step, as you can see, save the current routine context on stack and load a new routine context. Execute the new routine context and codes. On return, save the new routine context and switch for the previous routine by retrieving the saved context. So this process is going on in similar manner in terms of context switching. Ultimately, each and every time we have to follow the strategy. We have to take a context, we have to load the new routine data, we have to execute the new routine codes, save the new routine context and switch for the previous routine by retrieving the saved context. So as you can see, context switching in case of multiple interrupts, as you can see, ISR program means context switching at time t1. Highest priority, it will be decided by the priority ISR. So as you can see, the context switching t2. So basically, the state after t1 plus t1 t dash, where the t dash is the context switching time. So ultimately, based on the priority, that how you can choose a specific task, that it can be calculated or it can be decided with help of a context switching or context switching mechanism. Then you have to discuss or deal with a multiple number of tasks. So I hope that you are getting the idea about what exactly interrupt source is, context, multiple interrupts, context switching, and different mode of ISR. So I hope that you are getting the idea of what exactly the meaning of context switch is, ISR is, context is, multiple interrupt is. Still, if you have any doubts, you can feel free to contact me. So thank you for watching.